Question 1 from the 2017 Higher Physics Examination. The graph shows how the velocity of an object varies with time, and we can see the graph there. The graph shows us that at 2 seconds the velocity of the object is 5 meters per second, and 8 seconds into the journey the velocity will be 10 meters per second. So we have to find the acceleration of the object, and there's our 5 choices. Well, we know right away when we're dealing with graphs that the acceleration of an object, acceleration A, is always equal to the change in the velocity, delta v, divided by change in the time, delta t. That's the definition of acceleration when we're looking at a graph. So all we have to do is find, first of all, the change in time. So we're going to go from the 2 seconds to the 8 seconds mark, and the change in time across the way is going to be 6 seconds. And then we go immediately up from that, just like a step, and we can see that the change in velocity is going from 5 to 10 meters per second. So you've got delta v equal to 5 meters per second. The change in velocity is positive, therefore the acceleration is going to be positive. So all we have to do in this question is just put in our numbers. The acceleration is going to go to change in velocity, which is 5 meters per second, 5 ms minus 1, and divide that by the change in time, which is 6 seconds. So we have 6 seconds there. And if we do that on our calculator, we get the following answer, 0.83, and the units are going to be meters per second every second. That's how we work out the acceleration from the graph. So our answer will be answer A. Question 2 from section 1 of the 2017 Higher Physics Examination. A block is resting on a horizontal surface, big block of wood, and a force of 24 newtons is now applied as shown, and the block slides along the surface. The mass of the block, we're told, is 20 kilograms. The acceleration of the block is 0.20 meters per second every second, and the force of friction acting on the block is, and we're given 5 choices. So in this situation, let's identify all the possible forces acting on it. Well, we know we've got to find a force of friction, which must mean that acts in the opposite direction to the force. I'm just lining it up like that on the block. And also we're going to have an unbalanced force. And the unbalanced force, we know, is going to be the force causing the acceleration, and that's going to be towards the right. The other thing we have to do is look at the 24 Newton force, and it's an angle of 60 degrees to the horizontal. So we have to resolve the horizontal component of that force, and to do that it just would be 24 times cos of 60. So there's all our forces lined up, and we know we can work out the resultant force, unbalanced force, by taking the forward force, 24 cos 60, and taking away the force of friction. But let's work out first of all the unbalanced force, which is causing the acceleration. And we know that the unbalanced force which causes any acceleration is always equal to the mass times the acceleration of the object. We're told the mass is 20 kilograms, and we're told it's accelerating forward at 0.20 meters per second every second. So therefore the unbalanced force causing that is going to be 4 newtons. So we now know the unbalanced force is 4 newtons. Now what we've got to do is just sum all the forces. We know that the unbalanced force, FUN, unbalanced, is got to equal to the forward forces, which are going to be 24 cos of 60 degrees, and subtract the force in the opposite direction, which is going to be the frictional force. So we already know that the unbalanced force is 4, we'll just leave out the units. 24 cos 60, a good hint is always get to know what cos 60 is. Cos 60 is a half, so it's going to be 24 times a half is going to give you 12, and take away the frictional force. And look, we've got a simple little balancing equation. Take the frictional force F over the other side, it changes sign. Take away the 4 from the left hand side over to the other side, and it leaves 12 take away 4, and the answer is going to be 8. So for the frictional force acting on that block to give it that acceleration with the forward force of 24 newtons at an angle of 60 degrees will be 8 newtons, and the answer for that one will be B. Question 3 from section 1 of the 2017 Higher Physics Examination. The graph shows how the vertical speed of a skydiver varies with time, and we're showing the graph there. A student uses information from the graph to make the following statements. Statement 1. The acceleration of the skydiver is greatest between P and Q. Statement 2. The air resistance acting on the skydiver between Q and R is less than the weight of the skydiver. And statement 3. The forces acting on the skydiver are balanced between R and S. So we're given which of the statements below is or are correct, and we're given our usual 5 statements, combination of statements. So let's look at statement number 1. The acceleration of the skydiver is greatest between P and Q. But if you look very closely at the section of the graph P and Q, you can see that the vertical speed is not changing. Therefore, the acceleration has got to be equal to 0 at that particular point. And therefore, it can't have the greatest acceleration between P and Q. So statement 1 we can rule out as wrong. Statement 2, on the other hand, is the following. It says the air resistance acting on the skydiver between Q and R is less than the weight of the skydiver. So once again, let's look and see a diagram of the skydiver with that statement. And there's a statement there. The statement is saying that the air resistance acting on the skydiver is actually less than the weight of the skydiver. Now, if that was the case, you can see that the resultant force is going to be bigger in the weight direction. It's going to be bigger acting down the way. Therefore, you're going to have an acceleration acting down the way. Therefore, you're going to have an increase in speed. But you can see from the graph between Q and R, the speed is not increasing. It is in fact decreasing. So to say that the air resistance acting on the skydiver between Q and R is less than the weight of the skydiver is wrong. So we can mark that one wrong. What about our third statement? The forces acting on the skydiver are balanced between R and S. Well, once again, you look at R and S and ask yourself the question, is this vertical speed changing? And the answer is no, it's not. It's staying constant. So a constant speed means no acceleration, which means that the forces acting on the skydiver are actually balanced. So we can draw it like that there. The resistance due to the air is exactly the same as the weight acting down the way. Therefore, the skydiver will have balanced forces acting on him at that particular point. So statement 3 is in fact correct. So let's look and see what we've got. We have only statement 3 is correct, and it looks like the answer is going to be C. So the answer is going to be C. Question 4 from section 1 of the 2017 Higher Physics Examination. A spacecraft is travelling at a constant speed of 2.75 times 10 to the power 8 metres per second relative to a planet. A technician on the spacecraft measures the length of the spacecraft as 125 metres. An observer on the planet measures the length of the spacecraft as, and we're given our 5 choices. Now, the speed of the spacecraft relative to the planet is 2.75 times 10 to the power 8 metres per second. And that's approaching the speed of light. So we have to take into consideration the relativistic effects when these things happen. So we draw a picture of the situation. We have the spacecraft moving past the planet at that given speed. You can see that the spacecraft is moving 2.75 to the 10 to the power 8 metres per second, and the technician on the spacecraft is going to measure what we call the proper length of the spacecraft, 125 metres. Remember, the technician realises as far as he's concerned, on the spacecraft is not moving. So he measures that as 125 metres, and that's called the proper length. But it's the observer on the planet which is going to measure the relativistic length of the spacecraft. So look up your data sheets for your higher, and you'll find out this equation is there. The relativistic length of the spacecraft is going to equal to the proper length of it multiplied by the square root of 1 minus v divided by c all squared, and remember that's going to be the complete square root. Now we know v and know c, so we can actually get rid of the v and c, make it much easier to deal with. V divided by c, if we just look at the two ratio 2.75 times 10 to the power 8 divided by, and we're going to have 3.00 times 10 to the power 8. It just makes our calculation easier to put down. Do that in a calculator, we get 0.916. Now we can put the V upon C into the equation. So the relativistic length L prime is going to equal to the proper length 125 times the square root of 1 minus, and it's going to be 0.916, and remember we bracket around that to square that, and it's the complete square root of that sum inside. So when we do that in our calculator, we end up with an answer which is very close to 50 metres. So you can see that the observer on the planet is going to measure a smaller length than the spacecraft. So in this case, the answer to this question 4 is going to be B, and the answer from the list will be B. Here's a little bit of bonus material for you to try out yourself. I want you to construct a graph, and the graph has to be on the x-axis, the graph will be the value of the speed of light, and on the y-axis it will be the measured length of the spacecraft, the relativistic length of the spacecraft as it passes you. So when this spacecraft is sitting right across from me, the Captain Kirk on it would measure it as 300 metres, and I would measure it as 300 metres. But if that spacecraft starts to whiz past me at these different values, watch how the length changes. You take a note of them, plot a graph and see what you get. So 0 speed of light, we're going to have 300 metres. But if I move that to there, record your answers, record your answer, now, did you record all your answers there? Take a note of them, draw a graph, and see what graph you get.